good morning, Year 8. So today we're going to be doing polygons and looking at a whole lot of things to do with the angles in polygons. So a polygon is a figure or a shape that is closed. That means you can contain an area inside it. So you wouldn't have something like this with no side there. Like imagine putting some animals in that area there, they just walk straight out. Okay, so it's closed. And it has straight sides. You can have any number of sides, just no curves. Okay, so in a regular polygon, the word regular means that the sides have to be equal and the angles have to be equal. Okay, so the next thing you have to learn is convex or non-convex polygon. You did do this in Year 7, but just a reminder, a convex polygon is one where you have all the angles are less than 180 degrees. So if you look at this shape here and look at every angle, they all look like they're less than 180 degrees. This one looks like it could be a right angle, 90 degrees, that's less than 180. This one looks like it might be a right angle. That looks like an obtuse angle, so that's less than 180. So they're all going to be acute or right angles or obtuse angles. A non-convex polygon has one reflex angle. So if you look inside this shape, you'll see that angle inside the shape. That angle is a reflex angle. So what happens is it actually comes back in on itself. So I like to think of it as if I stood inside here and I just blew out, I exhaled, it pushes out as far as it can possibly go. This one here, I'm actually inhaling. So when you inhale, things start to suck in towards you, and that's what this bit here is doing. Okay, so we're looking at angle sum of a polygon now. So to find the angle sum of a polygon that's got more than 4 sides, we need a way of working that out. So we know the angle sum of a triangle is 180 degrees. We know the angle sum of a quadrilateral is 360 degrees, because that's really just 2 triangles. So for any polygon, we start at a corner or a vertex, and we join from that vertex to every other vertex. That forms triangles, so we count those triangles. Now every triangle has 180 degrees, so the angle sum for your polygon will be 180 degrees times the number of triangles that you have. When we go through the examples, I'll explain that in more detail. The second method is to learn a formula. Our formula looks a little bit like this. It starts with angle sum equals 180. Now the number of triangles we put as n minus 2, and n represents the number of sides or angles in the shape. So really what it's saying is that if you get the number of sides or angles and take away 2, that's the number of triangles you're going to have, and we'll see that ourselves in a minute. So the next part, we're finding the interior angle of a regular polygon. So a regular polygon has all its angles the same. So after you find the angle sum of the polygon, if all the angles have to be exactly the same, you're going to take that angle sum and divide by the number of angles. So if we put that in a formula, the angle sum was 180 times n minus 2 in brackets. So put that in. The number of angles is n, because that's the number of sides or angles. So we create a formula for the interior angle of a regular polygon. Make sure we write this in. Okay, so we're going to come back in the next video and just do some examples on this work.